Internal spreadsheets can be used to change values in our simulation without editing the simulation model itself. Let's build a model in which we have 3 different activities and 3 different product types. Each product type takes a different amount of time to process within each activities, like it is in a table. The following steps show you how to set up the simulation so that these values are read in from one of Simulate internal spreadsheets. First of all, we need to create a simulation model like the one on the screen right now. To create a spreadsheet, go to Data and Rules and select Spreadsheet option. We click New. Now we can give our spreadsheet a name. The spreadsheet will be used to hold the timing information, so let's call it Spreadsheet Timing. Now we already can access our spreadsheet from Spreadsheet Options, access timing right here. Let's open the spreadsheet and enter all the values like those in the table. So we will have 3 columns represent for 3 activities, and we have 3 rows represents for 3 different product types. Now let's enter the data. 20, 30, 45, 120, 240, 3, 2, 1, and we have 90, 60, and 30. Okay. We'll look at how to preference these values shortly. Now it's time to link the activity's timing to the spreadsheet. It is possible to change the timing of an activity so that it preferences a particular cell in the spreadsheet. In order to set this up, we use the formula editor. Basically, we should select activity number 1, go to Properties tabs, and this one is what we call the formula editor. We can click on these 3 dots and we can find a spreadsheet we just created, which is access timing. This is activity 1, and we are only going to consider product type 1 at the moment. So we preference column 1 and row 1. It is worth noting at this point, as default, Simulate use the convention column and row for cell. Then we click OK. So the activity 1 timing box should now look like this one. Whenever a work item enters the activity 1, our simulation will preference the appropriate cell of SS timing spreadsheet to get the timing information. Now we can modify the timings for activity 2 and 3 as well. So just select activity 2, do the same. We specify the timing for the activities based on the spreadsheet we just created. And activity 2 should refer to column 2, and product type 1 should refer to row 1. The same for activity number 3. We specify the timing from the spreadsheet. We should refer to the 3rd column from the spreadsheet for activity number 3. And we are currently consider product type 1, so the row will be number 1. So let's change back the name just for easy. Q1, Q2, and Q3. We now have the simulation model where the product type 1 takes a different amount of time in each activity based on the values in our spreadsheet. The next step is to add another 2 product types. First, we need to create a new label called LBL type. Go to data rules, labels, add label. Let's call it LBL type. You can refer to the label videos for more information on how to do this. Next, we attach LBL type in our start point object. And set it so that all 3 values, type 1, 2, and 3, are equally likely, which means they will have the rounded uniform distribution between 1 and 3. We can add actions, set to, and specify it will follow the rounded uniform distribution between 1 and 3. We now want to vary the row we look at based on the label we just created called LBL type. Instead of always referring to row number 1, we want to look at row number 2 or 3 if our label LBL type is 2 or 3. And to do that, we select activity number 1. We change the cell preference for activity 1 to SS timing column 1 row based on the label we just created, which is LBL type. All right, and we will do the same for the other 2 activity. So this one should be SS timing column 2 row LBL type. And this one should be column 3 row LBL type. All right. Of course, we can change the queue's name to make it shorter. It's time to run the model. And to make it even easier, we change the clock setup from time and day to symbol unit count to see the minute units. Okay, it's time to run the simulation. And in order to ensure our simulation is working as expected, it is important to test the way it behaves. And we can use the step control to view our simulation model event by event. Okay. All right. So now let's check the current content in activity number 1. Currently, activity number 1 is processing product number 3, which arrived at 61 minutes and scheduled to leave at 148. The difference between entering time and leaving time is roughly about 90 minutes. And if we compare that 90-minute number to the table, we see that to process product type 3 for activity 1, we need around 90 minutes. So it confirms that the simulation model behaves exactly from what it reads into the spreadsheet.